A, B, C, D, E, F, G all the way forever, but you run out of letters after 26, so you don't run out of numbers. You could, yeah, and then that will get messy. At least when you see A 1023, you know exactly where it is in the list. Okay, so what's the second one in this expansion? A1x1 plus A2x2?
Plus A3x2.
Yeah, so what is this?
A series.
It's just a general series for any polynomial, isn't it?
Yeah.
Any polynomial will have this series. Like A might be 0, it could be 0. A1 might be 0. In other words, there's no x term. It could be like a quadratic, could be written here. 2x squared, 3x, and if A0 is 4, that's a quadratic. It could be a quadratic one. But this is just any polynomial. It's just any polynomial. So it's saying that x divided by sine x gives some polynomial. And we're going to find, if we find out what A0, A1, A2, and so on are, we'll have what x divided by sine x is. Now, the thing about Maclaurin series is they're much more easy to multiply than divide. So if I do like a common denominator thing here, well, I already established that is what? What did we establish this was? A0 plus A1x1 plus A2x squared and so on multiplied by sine x is equal to x, yeah? Okay? Use the Maclaurin series for sine x. Use the Maclaurin series for sine x. We have a Maclaurin series for sine x, so I can replace sine x with the Maclaurin series. And as soon as I have that, I have a polynomial times a polynomial equals x, which means I have a left-hand side equaling a right-hand side just in x's that has to match up. Does that follow?
Yeah.
So, and then I'll be able to find what A0, A1, and A2. Because we know from like all our factor theorem stuff earlier on that if we have, let's say, ax squared plus 6x plus 7 is equal to 5x squared plus 6x plus 7, we know that A has to be 5, yeah?
Yep.
A has to be 5. All right, so let's apply the sine x one. What's the sine x Maclaurin series from our formula booklet?
X minus x cubed over 3 factorial plus
Thank you.
x over 5 factorial minus.
Yeah, okay. Yeah, we get it. Okay. So these two multiply to give this. How many terms do we need to find? To find A0, A1, A2, the first three constants. So I only need to care about I don't need an A3 here. All right, so I'm just going to multiply what I have. A0 has to be multiplied by all these. Yep. So A0x minus A0x cubed over 3 factorial plus A0x5 over 5 factorial. Yeah, that's a 0, not 6. Okay. I also need to do, there's more multiplications here, but I'm not going to do them. A1 times this and this. And this. So what do we get? Plus A1 x squared, yes. Minus A1x cubed over, 4 over 3 factorial. Okay. Can anyone see
Oh, there is some sort of pattern.
well, maybe it's a pattern, yeah. This times this. This times this gives, there's more here, but this times this gives A2x. A2. Did I do the last multiplication with A1? No, I didn't. I skipped it. I didn't mean to do that. Plus A1 x6 over 5 factorial. Oh, and then we've done a lot of multiplications here.
Why does it take so long?
Eh.
Are you showing us this?
I'm doing a bit more than I should. Maybe I should have stopped earlier, but I'm doing them all. We'll do all 9 just to see that we have exhausted the process. A2 over x cubed, yeah, A2 x cubed, A2 minus A2 x5 over 3 factorial, and plus A2 x7 over 5 factorial. All right, all that and many more multiplications just equal x. And that's crucial. Just equal x. So what can I compare on the left-hand side to the right-hand side?
The x A0. A0 is 1.
A0 is 1.
Bang.
Do you see that?
Yeah.
Because there's the only thing. Does that mean, because they're the only two things I compare x terms on. So A0 is 1. Does that mean A1, 2, 3, 4, and 5 are all zeros?
No. What? Wait, what?
Yes, it does.
Yes. Wait, what did we just say?
It does. It's all, yeah, it's all zero.
We need, remember what the question asked, we need to find these ones.
They're all zero because otherwise it wouldn't make any sense.
Don't high five yet.
Wait, no.
Don't you high five yet. Which means every time A0 is written, it's now 1. We happy with that?
Oh, yeah, it doesn't make sense.
1. 1. So I'm just gonna remove those. They're all 1s. Any other A0s? No. There's nothing to compare to on the other side, though, is there? No. Well, there is. 0 x squared plus 0 x cubed. Yeah. Well, let's look at x. Is there any other x squareds? Any other x squareds? There's 1 here. Anything else? Nope. Okay. A1 x squared equals 0 x squared on the other side, so that means A1 is 0. Very good. Done. So anytime A1 is written, that's gone, yeah? Because A1 is 0, yeah? That one's gone. A1. That one's gone. A1. That one's gone. Right. X cube's next.
X cubed over 3 factorial plus A2 x cubed. A2 is
This,
Positive 1 over 6.
this have to equal 0. So x cubed over 3 factorial plus A2 x cubed have to equal 0 x cubed. Oh, this one's negative? Sorry.
Negative x cubed over 3.
Oh, this one's negative. Sorry. Yeah, you're right, of course. All right. So what's A2?
1/6.
1/6. Yes, very good. So the x cubes will all cancel. This is 6. So you get negative 1/6 plus A is equal to 0. So A is equal to 1 over 6. And now we've done it.
Let's go.
All right.
Wait, why does it say?
What?
It's not even that hard.
Wait, now you have to find x over sine x. Now you have to add them all up.
Use the Maclaurin series. So what have we found?
No, it just says 5.
No. But you're right. What is the Maclaurin series then? What's the first 3 terms of the Maclaurin series for this? Because we've said it's some polynomial. We found out what A1 is.
It's 1 plus.
Or A0 is 1 plus. Yeah. Oh, not x. Yeah. We don't know what the next one is. But if we really wanted to, which we really don't, we could find the next one. All right. All right. You guys do something. I don't know what.
But so we kind of did have to do it that